All right, so I'm going to go ahead and start the recording today. This is November the 7th. This is Math 0310. And first of all, I want to kind of give everybody a heads up who's going to watch this video and who's watching it right now, is that the recording, I've been unable to upload lectures to YouTube starting yesterday. I have not had any problems with this at all semester. It's gone really well since early September, and I've uploaded, 40 videos or more now, 40 lectures or more total for the semester. And all of a sudden yesterday, I started having some serious issues and was not able to upload any of my lectures from yesterday, and I'm still struggling with that this morning. So just to give you a heads up, they gave me a possible solution. The company that makes the software that I use for recording these lectures, and so I've started that solution, and so we'll see if that actually works. But I just want to kind of give you a heads up that it's possible that your lecture may not go up, or a link to your lecture may not go up later, like they have been. If I can't actually upload it to YouTube. So we'll kind of monitor the situation. I will certainly email you if I'm continue to have issues. Remember that the written notes always go up on my Google site also, so you can always get access to my written notes. But the actual video with audio and all that, we'll see. I'm going to try to upload this as soon as the lecture is over, like I always have been, but we'll see how that pans out. So I wanted to kind of give you a heads up on that. We have started in on graphing lines, and so we have started graphing last time. So last time we began graphing. And also, I wanted to kind of give you a heads up on WebAssign. And I believe I sent an email out to everybody about WebAssign yesterday, I believe. Did any of y'all get that email about WebAssign and the due dates? Okay, so Sandra let me know that yes, you did. All right, Charlotte, what?
I said I might have, I just haven't checked.
Okay. Well, you had some due dates, and so check those due dates, and I've kind of rearranged them a little bit and postponed and gave you a few extra days on some things. So just kind of be paying attention to due dates. And remember that I drop the lowest 4 WebAssign grades. So if you've missed a couple, that's not a serious issue, because I will drop the 4 lowest. So you could miss up to 4 and it wouldn't impact you at all. And even if you missed 5 or 6, because I dropped 4 and because you have so many WebAssign grades, that really won't affect you very much at all either. So kind of pay attention to that. And then also exam 2, the grades are uploaded to your WebAssign gradebook. So be looking for your grades for exam 2. Remember that and I've emailed you about this also, but remember you go to grades and then raw scores, and then after grades and raw scores, then you click on exams, and you can actually see your exam grades. And if you want your graded exam sent back to you, please email me for the graded exam. If you email me, I will send the graded exam back to you. As an attachment. Be aware that I'm still working on my calculus classes grades. And so if you email me now, which is fine if you do that, but if you email me today, I probably won't respond to that email until probably later in the week, probably until Thursday or Friday before I actually send it back to you. So, because I need to get my calculus grades finished, and they usually take a little bit longer, and so I'm currently working on that right now. So just kind of be aware of that also. And now we're starting to lay the groundworks for exam 3, and so we're coming out of solving quadratic equations, and we've started talking about graphing lines. So does anybody have, before we get started, does anybody have anything really pressing that they need to talk to or ask about here, whether it's on content or exam 2 or whatever, before we move on? Anybody have any questions?
No. I'm good.
All right, so sounds like we're good, and so from everybody. And so we're going to move on to graphing. And so last time we had started talking about graphing lines. And we were talking about, remember, linear equations in 2 variables. And that's been the big transition, is that we have, when we left quadratic equations back in chapter 10 and now have moved on to graphing lines, we've moved from equations in 1 variable to equations in 2 variables, right? So far, up till last time, every equation we looked at in class was an equation in 1 variable. And so now we've started looking at equations in 2 variables. And remember, when you move on to equations in 2 variables, you are talking specifically about graphing in the plane. All right, and so we started talking about that last time, and the most basic graph that you can look at in a plane is the graph of a line. And so that's what we started talking about. In my college algebra class, we've looked at all sorts of graphs, much more complicated than lines. But that lines was something that I expected that they had seen already. And we went through it very, very fast and did a really quick review, really just a day in college algebra. And we reviewed everything, all the basic things about lines, but then we moved to more complicated graphs. In this class, we will look at some other graphs besides lines in a day or two, but we're going to center on lines and all the important basic features of lines. And then you'll use some of those ideas that we talk about with lines in other more complicated graphs. Now, so far, what we've done is we've started talking about graphing equations, linear equations in 2 variables. And so remember, a linear equation are first-degree equations. First degree, so that means all the variables are raised to the first power, and all the terms are first-degree terms. And a linear equation in 2 variables is an equation that you can write like this: ax plus by equals c. So if you have an equation in that form, ax plus by equals c, notice the x is raised to the first power, the y is raised to the first power. A, b, and c are just constants. And when you have an equation like this, you get a linear equation in 2 variables. And so one thing we talked about last time is graphing by just plotting points. So if we had this example, as an example, let's say we had 3x plus y equals 4, and we wanted to graph that by plotting points. Then what we would do is we would make a t-table out, and we would pick x values and then solve for y. Now, when you plot by a graph by plotting points, a lot of times what makes sense to do is to take the equation and rewrite it in a little bit different form by solving for y. So if we solve for y in the equation, I did not talk about this last time. You don't have to do this at this point for plotting points, but it certainly a lot of times makes things a little bit easier, is to get the y by itself, and you write the equation in the form y equals negative 3x plus 4. And so when you have the equation like that, solve for y, right? The y is by itself. Then when you substitute in x values, like I might substitute in negative 2, negative 1, 0, 1, and 2 as an example, nice representative x values there, then it's pretty easy to do the arithmetic, because all you're doing is plugging those numbers in for x and calculating the y value. Right, so if x is negative 2, then y is negative 3 times negative 2 plus 4. So that's 6 plus 4, or 10. And when x is negative 1, you have negative 3 times negative 1 plus 4, which is 3 plus 4, or 7. When x is 0, you have negative 3 times 0 plus 4, which is 4. When x is positive 1, you have negative 3 times 1 plus 4, which is negative 3 plus 4, or 1. And then finally, when you substitute in 2 for x, you have negative 6 plus 4, or negative 2. And so you have a good group of points here to plot. Now, I wouldn't be able to get all of those on the same coordinate system here, but at least I'd get a few of them on there, and enough to make a decent sketch of the graph. So negative 2, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9 is way the heck up here. And back up into the notes up there. Negative 1, 7. 1, 2, 3, 4, 5, 6, 7 is right here. 0, 4 is here. And 1, 1 is here, finally. And then 2, negative 2 is here. Right, so we plot those points, and then we get a, we have clearly, we see that this graph is going to be a line.
For the first one, is that 3 times negative 2 plus 4 equals 10?
Remember, it's negative 3 times negative 2 plus 4. Remember, because if you take, remember what I did here is I took my original equation, 3x plus y equals 4. Here's my original equation. And then I solved it first for y. In other words, I got the y by itself by subtracting 3x. And when I do that, the equation now looks like that. And so I just rewrote the equation at the beginning so that the y was on one side of the equal sign by itself. And then when I did that, it just makes the arithmetic easier. And so now I can just substitute in, right? And that's what I'm doing right here, right? For each one of these. I don't know. Janessa, I think you asked that. Is that okay?
Yeah, that's cool.
Okay. All right. So is everybody okay with that? So we've got the graph and we plotted points. We did this kind of thing last time in class. Now, there's a couple of things we really didn't get a chance to talk about last time. So I wanted to do a little bit more to kind of fill in some gaps with graphing equations like this. One thing we noticed is, and let me flip back real quick. One thing we notice is that because we know the graph for these equations is going to be a line, right? The graph is always a line. We don't really need to plot 5 points to sketch the line. In fact, we really only need 2 points to sketch the line. And so if we kind of operate under that assumption, so if we have 5x minus 2y equals, let's say, 8, if we only need 2 points, the 2 points that we might pick are the x and y intercepts. So we kind of modify this idea of plotting points. And so if we're talking about using intercepts instead to graph the line, the x and y intercept, then what we would do is we would kind of shorten this t-table, and we would put 0 in place of x, and when we do that, that would give us the y-intercept, and when we would put 0 in place of y, and that would give us the x-intercept. For one thing that's nice there is that when you use 0 for either x or y, the arithmetic is always going to be much easier because you're substituting in 0. Right? So when I substitute in 0 for x, I have 5 times 0 minus 2y equals 8. So you get negative 2y equals 8 because 5 times 0 is 0. And so you end up with y equals negative 4. And so there's our y-intercept is 0, negative 4. And then when you substitute in 0 for y, you have 5x minus 2 times 0 equals 8. So the 2 times 0 is 0, and so you get 5x equals 8. And then x is 8/5. And so you get the x value of 8/5 right there. So I get the 2 points, 0, negative 4, and 8/5, 0. When you have a fraction that's an improper fraction like that one, if you want to graph it, you ought to think of it as a mixed number, and 8/5 is 1 3/5. And oh my gosh, I had an improper fraction on a college algebra exam where they were graphing last week, and you should have seen all the crazy places they were putting this improper fraction. And so think of it as a mixed number, that 8/5 is 1 3/5, and put it in the right place. You want to be able to identify where these spots are located. All right, so I have my 2 intercepts. And even with those 2 intercepts, we can make a decent sketch of the line. We can make a perfectly good sketch of the line. That I have 0, negative 4 right here. There's my y-intercept. And then 8/5, 0, which is 1 3/5. That's 1 and a little bit past the half. So there's 8/5, 0, like so. And then we can sketch the line. What I would strongly recommend you do when you graph things for me on an exam, I would strongly recommend that you label the points. That way, if it's a little tiny bit off, but if you've labeled it correctly, at least you've kind of covered yourself there. So labeling it 0, negative 4, and 8/5, 0 makes sense to do, just to kind of make sure that it's not only clear to you, you're the one sketching the graph, but it's clear to me, and because I'm the one that you're trying to make sure that you're trying to convince me that you know what you're doing, right? So make sure that you label those points like that. All right. So using the intercepts, if I tell you to use the intercepts to sketch a graph of a line, then this is what I want you to do, is I want you to substitute in 0 for x and 0 for y like this. Now this can create some issues. So for example, if we had this equation, let's say we have 2x minus 3y equals 0. And you're looking at using intercepts for this graph, then when you substitute 0 for x and 0 for y, right? The y-intercept, we know we put 0 in, put in 0 for x, and the x-intercept, we know we put in 0 for y. Well, when you do that, and this problem, like when I put in 2 for 0, notice what happens. The 2 times 0 is 0, and you get negative 3y equals 0, and you get y equals 0. So the y-intercept 0, 0, and it's pretty obvious that that's going to be what's going to happen for the x-intercept also. When you put 0 in for y, clearly the exact same thing happens. And so this is a graph that passes through the origin. It passes through 0, 0. Well, how many points do you have there? You just have 1, right? Because it's the same point, 0, 0. So you don't have enough information to graph the line. So you must get a second point. And so what you might want to do here is to just pick an x value, and if you pick an x value, then you can calculate the y value that you need. Now, what would be a good thing to do here, maybe makes your life a little bit easier, is to do what I did on the last screen and take this equation and solve for y, like we talked about on the last screen. So when I say solve for y, that means get the y by itself. So to get the y by itself, you have 2x minus 3y equals 0. So I would subtract 2x from both sides. Remember, you're trying to get the y value by itself. So you have negative 3y equals negative 2x. And then finally divide both sides by negative 3. And you get y equals positive 2/3 x. And so, picking a x value here, if you think about it, you got y equals 2/3 x. Picking an x value that's divisible by 3 makes your arithmetic really nice. So if you put x equals 3 in, notice you get y equals 2/3 times 3, and the 3's divide out, and you get 2. And so you get a y value of 2. Now, I just picked x equals 3. You could pick any x value you wanted to. You could pick literally any x value you wanted to here, and you could calculate another point. You would definitely get a different point than I got. I got the point 3, 2. You might get another point. That absolutely does not matter here. We will both be getting the same line. That's the important thing. Regardless of what is the second point you get, it's going to be the same line in both cases. So I have 0, 0 is the x and y intercept, the origin is, and then I got the point 3, 2, which is right about there. Well, not right about there. That's exactly where it is. And so there's my graph, like so. You might have got a different second point, but that doesn't matter. You would have gotten the exact same line regardless, okay? So I just, kind of want to point that out, that sometimes the line goes through the origin, and if you're going to try to use intercepts to graph the line, then you're going to need a second point here. So be aware of that. And let me tell you right now, I absolutely promise that that's going to happen on your exam, exam 3, when because I'm going to ask you to graph some lines, and I promise there will be a line that goes through the origin. That's definitely going to happen. And so that's something you need to be aware of, that you're going to have to go out and find another point also in that situation. All right, the next thing we wanted to talk about, we're trying to tie up some loose ends on graphing lines here. So the next equation I want to look at is 3x equals, let's say, negative 9. 3x equals negative 9. Now in this equation, remember, linear equations in two variables are equations that look like this: ax plus by equals c. Hey, but this equation only has one variable and it only has an x. It doesn't have a y in it. Well, all that means is that the b value, in this general form, ax plus by equals c, it just means that b is 0. That's why there's no y in the equation. That's okay. That definitely can happen. What I would do here is I would just divide both sides by 3 and get the equation written like this: x equals negative 3. And if you're talking about plotting points to graph this, one second. All right, if you're talking about graphing by plotting points or by using intercepts or whatever, notice this equation is telling you that x has got to be negative 3. If you notice I couldn't put 0 in place of x here. That wouldn't work. No, because what does the equation tell you? The equation tells you that x has to be equal to negative 3. If you put 0 in for x, there's no way you could get a true statement there. It's not possible. So that can't happen. What do you have to put in for x? You have to put in negative 3. And because the y term, the coefficient of the y term is 0, it does not matter what you put in for y. Because you're always going to get 0 there. So I could get negative 3, 0. I could get negative 3, 1, negative 3, negative 1, negative 3, 2, and so on. As long as x is negative 3, y can be anything in this type of equation. And so what you get here is an equation. If you plot those points, you get negative 3, 0, negative 3, 1, negative 3, negative 1, negative 3, 2. What do you get? You get a line. Certainly you get a line, but you get a vertical line. So that's our equation, x equals negative 3. It goes through the point negative 3, 0. This is a vertical line. And in general, this is always going to be true, that when you have an equation that's x equals a constant, in other words, the y term is missing. If that's the equation that you get, the graph is always going to be a vertical line. Is always a vertical line. So I definitely want you to be able to pick out vertical lines when you see them, right? So if the equation is x equals b, it's a vertical line. The graph is a vertical line through b0, right? Whatever the b value is in the equation. So you really, if you know this going into the problem, then you do not need to do any plotting points or anything like that. You should be able to just sketch the line. So if I have the equation x equals 4, you shouldn't have to do anything here. You could just sketch the graph. You know by the form here that this is a vertical line through 4, 0. And so 4, 0 is right here. And you just sketch in the vertical line there. And there's your equation. I would recommend that you label the line x equals 4 like that, so it's pretty clear that that's what you're graphing. And you're done. You've got the solutions pictured for this equation, x equals 4. All right, so definitely something I want you to be able to pick out when you see it. X equals a constant, you get a vertical line for the graph, right? Definitely important that you see that. So now this is where y is missing, right? So obviously if we're looking at equations where y is missing, then we also want to look at equations where x is missing. And so next example, let's say we have 2y plus 10 equals 0. 2y plus 10 equals 0. Notice the x is missing here, no x term here. So this is exactly what we're talking about. Like the last problem, except now the x term is missing. Solve it for y. Get the y by itself. So you subtract 10, divide by 2, and you get the equation looking like this. Y equals -5. Right? And so if you're plotting points to make the sketch here, what is y equals -5 telling you? Well, it's telling you that the only way you could get an ordered pair that's a solution to this equation is if the y value is -5. So the y value is a constant here. X can be anything. It doesn't matter what x is. So all of these points, and literally it doesn't matter what x is, so I could put 1,000 or 10,387, and that would be fine. That would be a solution to that equation, and that point would actually be on the graph here. Now you're graphing it, so you know, if you want to put 10,387 in there, you could, but it'd be kind of crazy to do that, right? Obviously pick values that make sense because you're actually going to want to graph this. So here's our coordinate system. And I'm kind of putting some space at the bottom because I know where the graph is going to be. Right, you get 0, -5 right here. And then you have 1, -5, and -1, -5, and 2, -5, and so on. And what happens? All of these points lie on a horizontal line, like this. And that's our equation, y equals -5. So this is always true for equations like this. If you have y equals a constant, in other words, the x term is missing. Right? If you have y equals a constant, that the x term is missing, the graph is always a horizontal line, and it's passing through the point. If the equation's in the form y equals b, then it's always through 0b. Right? That's our y-intercept. So if you know that, going into a problem, that's that's going to be extremely helpful. So if I have y equals 3/2, for example, right? As soon as you see that equation, y equals 3/2, because there's no x, right? X is missing. You know that this graph is going to be horizontal. And you don't need to plot points or anything like that. You can just sketch the graph. And you know this is a horizontal line that goes through 0, 3/2. And again, there's an improper fraction. If you're having trouble with where that's located, write it as a mixed number, which is 1.5. And so you get that y-intercept, which is right there. And so here's our horizontal line. And again, I would label the line y equals 3/2 like that, label this point. Labeling things like this can only be to your benefit on a test, because I'm going to be the one grading it, and I'm going to want to know, you want me to be clear about what you're trying to graph. I will supply the coordinate systems on exams, and so because you're going to be doing a fair amount of graphing on this next exam, but I will be providing you with the grids to sketch those. You won't have to hand draw the grids at all. All right, so we've kind of taken care of all the different issues we need to deal with as far as plotting points and using points to sketch graphs of lines. And so our next stop with lines, now with linear equations, is the idea of the slope of a line. We want to talk about the slope of a line. All right, and the slope of a line is kind of a measure of how steep the line is. So it's a measure of how steep the line is. And it's also tells you the direction of the slant. Tells you the direction of the slant. In other words, does it slant up as you go from left to right, or does it slant down as you go from left to right? So up or down. And you're moving left to right. You're always moving left to right when you're talking about things like that. All right, the slope is typically, we represent this kind of for historic reasons with the letter M, the small letter M. Don't use a capital letter M, it's a small letter M for the slope. And the slope of a line is defined in words. And so a lot of you who studied slope in high school probably saw it written out this way as the rise over the run, which is a perfectly good way of describing the slope of a line, is that it's the rise over the run. So this is what that means. If you've got this line, and I would want you to be able to take a line where I give you the graph and be able to tell me what the slope is for that line. So let's say I have a line that looks like this. Well, and I kind of missed the points. Try it one more time here. That's better. Sort of. And so pretend that that's a line right there, and we want to find the slope of the line here. So to find the slope, you want to identify the rise and the run. And so what you do is you pick 2 points that you clearly know are on that line. And so the 2 points that I know are on that line, I kind of plotted them, this point right here and this point right here. Let's not even worry about the coordinates of those points just yet. So the rise is this distance right here. That's our rise. And because you're going up, the rise would be positive. And then this is our run right here. And because you're going to the right, the run would be positive. And so all you have to do is count. You're literally just counting here. And if you count the tick marks here, 1, 2, 3, 4, the rise in our problem on this one is 4, and the run is 3. And so the slope of this line is going to be rise over run. The slope of this line is going to be 4/3. Right? Notice I didn't even care about what the coordinates of those points were. I was just counting on the graph. And I could just count on the graph and figure out what the rise and run are from the graph, and I can figure out the slope. All right, so let's look at another graph, do the same kind of thing. So let's identify the rise and the run on this one. So notice in this problem, I didn't even give you any like actual dots on the line. I just drew the line right here and said, hey, find the slope of this line right here. So it's the same idea as the first problem. What we're doing is identifying some points that we can clearly see are on the line. And in this case, the intercepts make sense. You know, that intercept right there is at 0, 2. That's the y-intercept. And the x-intercept is at 3, 0. So if we're going to go and look at the rise and the run on this picture, so I'm always going to go from left to right. And when you're figuring out the rise and the run, you don't have to do that. You don't have to go from left to right. You can go from right to left, but I'm going to do it always left to right. That way I'm always going the same direction. So to go from the first point on the left, you go down in this case. So the rise is -2, and the run is this direction right here. And so that run would be 3. And so the slope of this line would be rise over run. And so the slope of this line is going to be -2 over 3. Now, technically, it's -2 over +3, the way I have it. But that, you know, the minus sign can be put really in any part of this fraction, in the front of the fraction, in the numerator or in the denominator, you're going to get the same thing. So notice that that last one, where the run is, or the rise is +2 and the run is -3. So what that would do here, if you use that instead, if you use this slope instead, then notice what happens. If I started with this first point, the rise would be +2, and the run would be -3. If you go back this way, and notice you are on the same line. So the rise is 2, but the run is now -3, so you're going back to the left, and you get a point that's still on that line right there. And so it doesn't matter which one you actually use. You usually see it written actually the first way with the negative sign just in front of the fraction. Make sure you know, this is very common for me to see students do this. When you have a negative in front of the fraction, that is not, it's absolutely not -2 over -3. Right? That negative sign is not on both the numerator and the denominator. It's just on one or the other. Because if it was on both of them, then it would be +2/3, right? And so make sure that you kind of keep the negative sign straight when you're looking at slope like that. All right, so now both of these pictures I actually gave you graphs, and you found the slope of the line from the graph. Now, if instead of doing it that way, if we just found, if I gave you 2 points instead and not any graph at all, so let's say we had these points, 3, -4, and 2, 8, 3, -4, and 2, 8, and we wanted to find the slope of the line through these points. Find the slope of the line through these points. Well, one thing you could do is you could graph them if you wanted to. You could certainly do that and then identify the rise and the run. But what we want to kind of do is we want to identify from this picture here, and I think I need to move that down a little bit at least. Let's go down here. What we want to be able to do is identify a way to find the slope of the line through those 2 points without having to draw the picture out all the time. All right, so 3, -4. Let's see, +3, -4. 1, 2, 3, 4 is down here. So there's 3, -4. And then 2, 8. And I tell you what I'm going to do is I'm going to cheat here and to get a point that's a little bit better than 2, 8 probably for as far as my graph. I'm going to say -2 and let's say 3. It's just going to be easier to locate this on the graph. So -2, 3 would be -2, +3 would be this point right here. So here's -2, 3. and here is 3, negative 4. All right, so if we're going to look at the rise and the run here, but I want to kind of shorten this so we don't have to draw this picture out all the time. So the rise would go down like this. And if you counted, just 1, 2, 3, 4, 5, 6, 7, like that. So it's negative 7. And here's the run this way. And that run, if you're counting, would be 5. Now, if you look at the rise and the run, that negative 7, all that negative 7 represents is really just the difference in the two y values. If you subtract the two y values, notice negative 4 minus 3. If you take the two y values and you subtract them, right, you get negative 7. And if I take the two x values and subtract them, 3 minus negative 2, you get 5. So really what you're doing here, when you're looking at the rise, you're really looking at the difference in the two y values, negative 4 minus 3, and the difference in the x values for the run. And so this would be 3 minus negative 2. Subtraction, remember, always gives you the distance between two numbers like that. And so if you're trying to find those distances, you could just subtract here. So that kind of gives us a way of dealing with the formula to be able to calculate this. So the slope, first of all, in this problem would be rise would be negative 7. The run would be 5. So you end up with negative 7/5 for the slope. Negative 7 over 5, technically. Now, notice what we could have done here in this problem is what I could have done is I could have started with the 2 points and just did the arithmetic from the 2 points. If I understand that subtraction gives us the distance, then I could have said 3 minus negative 4. Actually, I subtracted in the other direction down in the graph, so I'll do it that way up here. So negative 4 minus 3, and then 3 minus negative 2. And so that gives me negative 7 over positive 5. So in general, then, if you have a line that goes through x1, y1, and x2, y2, right, goes through those 2 points, then the slope of that line, you could just calculate, right, the rise over the run by simply subtracting the y values and subtracting the x values. So I write y2 minus y1 over x2 minus x1. In other words, subtract the y, subtract the x's. You just have to make sure you subtract them in the same order, right? So always subtract x and y values in the same order. Right, as long as you do that, and that's why I put subscripts on them to emphasize that we were actually subtracting them in the same order. So notice if you know that formula, and I'm going to go ahead and highlight that formula, so we kind of keep that in our memory, right? We want to know that. That's something we always want to be able to do. Then to find the slope of a line, let's say we have a line that goes through negative 6, 8, and negative 10, 15. Not even going to graph this then. I'm just going to find the rise and the run just from the arithmetic. So this would be y2 minus y1 over x2 minus x1. And so it'd be 15 minus 8 over, and notice I'm subtracting, I'm calling this point x2, y2, and this point x1, y1. It doesn't matter which one is which. Absolutely does not matter. Just make sure you subtract in the same order. That's all that matters. So you have 15 minus 8 over negative 10 minus negative 6. And so you get 7 over negative 10 plus 6. So you get 7 over negative 4. And so the slope in this case is negative 7/4. All right, so pretty straightforward. One thing I did not write down before, but we should start to observe that now, and certainly I think most of you probably are okay with this, but if the line slants up as you go from left to right, the slope is positive. And if the line slants down as you go from left to right, right, in that case, the slope is negative, right? That it's important to know that that the sign of the slope actually tells you the direction of the slant, whether it's slanting up as you go from left to right or whether you're slanting down as you go from left to right. Okay, so now let's look at some special cases with lines as far as the slope goes. So let's talk about a line, for example, and I'm going to start with the equation. Let's say we have a line with equation x equals 2. What is the slope of this line? Well, now we have already identified that, hey, this is an equation in the form x equals a constant. This is a vertical line right here. And it's a vertical line through 2, 0. So we could, plot 2, 0 there and 2, 1. And we could get this vertical line through 2, 0. There's x equals 2. But if we're looking at the rise and the run for this, well, notice that it's all rise and there is no run here at all, is there? Right? The line's not running in left or right at all. If you use the formula, remember you could subtract x's and subtract y's. So when I do that, in the numerator I get 1 minus 0, and in the denominator I get 2 minus 2. And so that gives me 1 over 0. Please do not tell me that 1 over 0 is 0. Right? That is not 0. That's undefined. And so for a vertical line, right, and so we're going to kind of write these three things together. If you have x equals k, you know that's a vertical line. And the slope for a vertical line is undefined. In other words, this is the one line that does not have a slope. And sometimes instead of saying the slope is undefined, you'll see the words no slope also written down for a line. There is no number to describe the slope of a vertical line. And so now I think you know what I'm about to do. That's the slope of a vertical line. So we obviously want to talk about the slope of a horizontal line also. So the slope of a horizontal line, we'll put that one down here. And I'm just going to draw a horizontal line here. So here's our horizontal line at y equals 3. So that's the equation y equals 3 right there. And so the points you might use are 0, 3, and 1, 3. And so when you look at the slope there, y2 minus y1 is 3 minus 3, and x2 minus x1 is 1 minus 0, and you get 0 over 1. Now that is 0, right? You can't, 0 in the numerator just gives you 0. And so what do we have here? That the slope of a horizontal line is 0. Definitely something that we want to probably maybe put boxes around in this case, because these are very important ideas, and also ideas that are frequently remembered incorrectly by students or misinterpreted by students. So we need to know when we see a horizontal line that has 0 slope and it has vertical line, you have no slope like that. If you need to figure out a way to keep that straight, students are frequently kind of confusing that. Think about the word 0 for 0 slope and the word no for no slope. And look at the letter Z and the letter N for those. And notice that the letter Z, you use horizontal lines to make the letter Z. And to make the letter N, you have to use vertical lines. Right? So, right, get it? So 0 slope, horizontal, no slope, vertical. So think of the letters Z and N. Maybe that will help you keep it straight, possibly. So hopefully that is maybe something you hadn't seen before and you hadn't thought about it like that at all. So, all right. So does anybody have any questions? I've kind of breezed through this introductory stuff on slope. Or are we doing okay? Anybody out there have any questions? All right. Okay. Sounds like we're okay. All right. So next question, or next stop. Then we're still talking about slope. The next thing I want to look at is, let's say that we have a line here, and let's say that we know that its y-intercept is at 0b, like this. And we know that the slope of the line is m, right? The slope is m. Now I want you to think about this line for a second. If we have another point on the line, and let's say the other point is any other point on the line. So since it could be any other point on the line, I'm going to just write xy for all the other points. And notice I didn't put a subscript on it. That means that that other point could represent any other point on the line. Then the slope formula, if we wrote the slope formula out for this line, we get m equals, and remember what the slope formula is, just y2 minus y1 over x2 minus x1. I'll go ahead and write that out. So in this problem, then, what would I get? I'd get y minus b, right, subtracting the y's, over x minus 0, like that, right? Just using the slope formula on those points. And so the slope would be y minus b over x. All right, and so what I want to do is kind of manipulate that equation. First of all, I want to get rid of the fraction, so I'm going to multiply both sides of that equation by x. Just multiply everything by x. So that gives me mx equals, and then the x's cancel on the other side, and you get y minus b. And then solve for y. So in other words, get the y by itself, and so I add b to both sides of this equation, and I get mx plus b equals y. Or, you could write it the other direction and write it y equals mx plus b. And that is a form for a line that has a slope of m and a y-intercept at b. Remember, the y-intercept was the b value at the beginning of the problem where that picture was. So this is always the y-intercept right here. And this the number in front of the x is obviously the slope. And this is actually called the slope-intercept form of a line. That's a big deal. The slope-intercept form. Definitely something that as a college algebra student, you will want to know. My calculus students, those of you who are science majors of some type and need to go on and take a calculus class, those of you who are business majors and need to go take a calculus class, all of you guys are going to have to take some kind of a calculus class, and you will definitely use the slope-intercept form in those classes to write equations of lines. That frequently comes up in certain kinds of applications. So what is this telling you? This is telling you that if you have an equation that's written in that form, y equals mx plus b, that you know some things about the line right away, right? That you've got this equation. So again, let me write it down. Y equals mx plus b. If you've got the equation y equals 3x plus 4, right away when you see that equation, you know some things about this graph. You know, first of all, that the graph is a line. You know that for sure, right? It's a linear equation. But then you also know that the slope is 3 for this line, that the rise over the run is 3. By the way, if you want to think of it as rise over run, you can think of it as 3 over 1. And the y-intercept is 0, 4. So you know a bunch of things about this line just from writing that equation down. And notice this actually gives you a way, if you wanted to, you could actually sketch the graph from that slope-intercept form. Easy enough, because you know that the y-intercept's at 4. So I'm going to move the x-axis down pretty far here. The y-intercept's at 4 right here, and the slope is 3, which means that if you look at the rise and the run, right, what do? You rise 3, and you run 1, like that, and you get another point on the line. And notice you could, if you wanted to, you could reverse it. You could fall 3 and go to the left 1, and you get the same line. Either way, it doesn't matter. And so you get some quick points on this line, and you get a quick graph right here. And here's our line. Right, and so gives you some important information about that line right away. So in this problem, and it also tells you the direction of the slant right away, doesn't it? Also, it tells you whether you have a rising line or a falling line, because you can tell what the sign of the slope is immediately. So y equals negative 2/3 x minus 1. All right, y equals negative 2/3 x minus 1. That equation is in slope-intercept form, and the slope is negative 2/3, which means it's a falling line. Right, it's a falling line because the slope is negative. It's slanting down as you go from left to right. And the y-intercept is 0, negative 1. Remember that since the slope is negative 2/3, you could think of this as either negative 2 over 3 or 2 over negative 3. It doesn't matter which way you think of the slope here in terms of thinking about the rise and the run. So making a sketch of this graph, the y-intercept is at 0, negative 1. So the y-intercept goes right here. And then let's say that we use 2 over negative 3 for the slope. Right, so that would say that the rise is 2. So the rise is 2, go up 2. And the run is back to the left, negative 3. And you can make a pretty quick sketch of the line. Right, and here's our line right here. All right, so this is a nice form because it gives you information about the graph of the line right away. So now, not every line is written in slope-intercept form. So this equation, 3x plus y equals 6, is not in slope-intercept form. But if you wanted to put in slope-intercept form, put in y equals mx plus b form, you could do that by just solving for y, right? So all you do is solve for y. In other words, get y by itself. Easy to do in this problem. You just subtract 3x, and you get y equals negative 3x plus 6. So right away on this line, the slope is negative 3, and the y-intercept is 0, 6. Right? You get that information right away about the line. So that's good. All right. This line right here, 7x minus 8y equals negative 4. If you wanted to put this equation, right, this is not in slope-intercept form. So if you wanted to write this in y equals mx plus b form, right, what are we going to do? We're going to solve for y. Right? Remember, that's what that means, is get y by itself. Solve for y. So in this problem, to solve for y, I would subtract 7x, right? Get the negative 8y by itself, and then divide both sides by negative 8. So you have to divide both sides by negative 8 like this. And so that's y on the left side of the equation. And on the right side of the equation, what you're doing here is you are dividing each term separately by negative 8. Right? So kind of, make sure you know you're dividing both terms in by negative 8. And because you're dividing both of them by a negative number, it changes both of their signs. So this is y equals positive 7/8 x. And then this would be plus, and 4 over 8 is 1 over 2. So in this problem, the slope would be 7/8, right? That's and 7 would be the rise, and 8 would be the run. And then the y-intercept would be 0, 1/2. So it would be, you get some important information about the line pretty quickly this way. All right, so let's see, next problem. So kind of a different slant to the same kind of problem. Let's write the equation of the line. So notice in this case, notice that you don't have the graph. What you're trying to do is actually, or you don't have the equation. What you're trying to do is create the equation. Write the equation of the line with y-intercept at negative 3 and slope of negative 3/2. All right, so what do we have here in this problem? We're actually trying to, our end result here is not a graph. Our end result here is an equation. That's what we're trying to do, is write the equation down for a line that has these features. So the y-intercept being at negative 3 means you've got the point 0, negative 3. And the slope we know is negative 3/2. So notice we can just put those two things and put them into slope-intercept form, right? Our slope-intercept form is y equals mx plus b. And so just substitute those pieces of information in, and you get negative 3/2 x minus 3. And that's our slope-intercept form. Now, you have to be careful if you read through, a textbook, like the textbook we're using, or other textbooks. If you watch other videos, I know some of you watch videos from other sources besides what you see in WebAssign or what I'm providing here with these lectures, which is absolutely fine. That's great. I'm glad you're doing that. That's good. But you'll see equations of like this kind of written in different forms depending on what people are asking you to write down. So you might be asked to write the slope-intercept form, in which case I'm done right here. This is slope-intercept right here. But sometimes you'll see that you're asked to write the equation in general form or in standard form, right? In general or standard form for a line. And so what they want you to do in that context, I'm writing down my equation again, is first of all, get rid of all the fractions that are in the equation. So there's a denominator of 2 in this problem, so I get rid of that 2 by multiplying everything by 2 right here on both sides of the equation, right? You're multiplying all the terms by 2. And so when you do that, you get 2y equals, and then the 2's cancel on the negative 3/2. So you have negative 3x minus 6, like that. And then finally, you add the 3x. The standard or general form is typically ax plus by equals c, or ax plus by plus c equals 0. Depends on the textbook or the software package you're using as to which they'll call standard or general form. And so I'm going to add 3x here, and I get 3x plus 2y equals negative 6. So you'll either see it written like that, or add the 6 and get a 0 on the other side of the equation and write it like that. So depending on the software you're using, on who wrote the problem, who's writing the directions, there's not really a standard form that you're going to see requested. Now in my class on an exam, I absolutely can tell you that on exams, I'm going to ask for slope-intercept form, and I'm not going to ask you for standard or general form. So on exams, I will always ask for slope-intercept form. And I will not ask you for general or standard form. Right? So I will always ask you for y equals mx plus b form. That's the form that kind of it leads you into talking about functions. And so that's the form that we want to write. That's the form I want you to write down. Okay. All right. So let's see. We wrote the equation of a line. So we kind of now want to go into the last thing we're going to deal with today. One more special form for a line, and then we'll be finished with that for now. And then we'll pick up with equations of lines again on Thursday, and do some things with equations of lines on Thursday. Okay, so remember how a few screens ago, when we started the slope-intercept form, we started with a picture of a line that went through, in particular, the y-intercept and then another point. All right, so the point that we knew on that line was the y-intercept. It went through 0b. So now what we're going to do is we're going to start with the same kind of picture, except now what we're going to do is we're not going to start with a really specific point like the y-intercept. We're going to say that this line just goes through the point x1, y1, and who knows where the point x1, y1 is. It might be on the y-axis, it might not be. So it's not the y-intercept specifically here. So this x1, y1 just represents any old point on the line. I'm sorry, not any old point, one specific point on the line. Let me take that back. One specific point on the line, but we don't know, it could be anywhere right there. And then xy, this represents all the other points on the line. So that's the variable. So this is a constant right here. You know this. And this is a variable over here. In other words, this represents all the other points on the line. All right. So what would be the slope of this line? Right. Well, let's, just like we did on that last picture, we start with the slope formula. And remember, the slope formula says subtract the y's, so it's y2 minus y1 over subtract the x's, x2 minus x1. So in our problem, subtracting the y's, you'd have y minus y1, and then subtracting the x's, you'd have x minus x1. Now remember, x and y are variables there. x1 and y1 are constants, right? So x and y are variables here. x1 and y1 are constants. All right, so you get that form right there, and then what we would do is we would get rid of the denominator, multiply 3 by the least common denominator, and so we have m times x minus x1 equals y minus y1. Or if we kind of turn that around, and it's more commonly written this way, y minus y1 equals m times x minus x1. And that is also an important form for a line. That is called the point-slope form. It's called the point-slope form for a line. And the reason why it's the point-slope form is because, first of all, you have the slope, right? That's m. And then you have that x1, y1 is a point, right? And that x1, y1 appears there and right there. And so what do you have? You have a point on and a slope. And when you have a point and a slope, you can write that equation out like that. All right, so this actually gives you another way to write an equation for a line if you know some information about the line. So this will probably be about our last example of the day. Maybe we'll work two like this. Let's say we have a line that passes through 2, 4, and the slope is 5. Write the equation for this line. And write the equation in slope-intercept form. That's how you want to finish. Well, because we have a point, right? We have a point right there, and we have the slope. If the slope is 5 right there, we can use the point-slope form of the line to write this equation. So we use the point-slope form to start the problem. So I would always write the point-slope form down right away when you're starting a problem like this. So it's kind of sitting in front of you like that. And you're literally just dropping these numbers in, right? That x1, y1 is our 0.24, right? And so this would be y minus y1, which would be 4, equals m, which is 5 in our problem, times x minus x1, but x1 is 2. Right, and we've written the equation for the line. The only thing that I've asked you to do is I've asked you to write the equation in slope-intercept form. And so this is the point-slope form for the line. This is the point-slope form for a line. And so to write it in slope-intercept, we solve for y. So now solve for y. So when you solve for y, first thing you want to do is get rid of the parentheses. You get 5x minus 10. And then finally add 4 to both sides. And you get y equals 5x minus 6. And this is the slope-intercept form. And that would be the form that I would ask you to write out. Like that. Guaranteed, absolutely guaranteed, you'll have a problem like this on exam 3. Exactly like this problem. Right? So if you know the point-slope form, then it's not a hard problem to solve. All right, one last problem. Same kind of problem, but the arithmetic, much messier on this one. Let's say we have that the line passes through -5, 4, and the slope is -2/3. So the arithmetic on this problem is worse, basically, and I frequently see students kind of mess up the arithmetic on this kind of problem. So we start with point-slope. I write out the point-slope form of the line. Y minus y1 equals m times x minus x1. X1, y1 is -5, 4. So this would be y minus 4 equals m, which is -2/3, times x minus x1. Now you have to be careful here. This is x minus x1, but x1 is -5. Right, so it's x minus -5. And so notice that is x plus 5. Most students will end up just writing out x plus 5 right away, but I want to make sure you saw why you got x plus 5 there. Now, go ahead and multiply this out, and we're going to put this in slope-intercept form, so I get rid of the parentheses. So I multiply through by -2/3. So this gives me -10/3 over here. And then I add 4 to put this finally in slope-intercept form. And oh my gosh, the fraction arithmetic on this is just very, very much a struggle for some students because we're adding the 4 here. But you've got to do this fraction arithmetic. And I see all sorts of crazy, crazy stuff here. But you're trying to get a common denominator. That 4 is really 4 over 1, right? And the common denominator is 3. So you're multiplying the 4 by 3 over 3. And so this would be plus 12 over 3 right here. And so you end up with y equals negative 2/3 x plus 2/3. And that's our slope-intercept form for the line. That would be the form I would ask you to write out at the end. Here's the slope-intercept form on the problem before it. All right, does anybody have any questions about that problem or any of the problems we've just talked about? Anybody have any questions?
No. I'm good.
Okay, so let me write. I have two things to tell you, so don't go away yet. Textbook homework, first of all. I have something else to tell you after this, so just real quick. So textbook homework on section, this is on page 481 of your book, of your textbook. This is problems 227 through 277, but I would think every other odd would easily be okay there. I want you to get some practice with slope, but if you work every other odd, you should be fine on that. Definitely fine there. On page 507, I want you to work problems, and again, it sounds like a lot of problems, but I want you to go from 289 through 335. Again, every other odd would be more than enough probably for those problems. That would be fine. And then finally, one last group of problems is on page 525, problems 387 through 399. 387 through 399. Next time, we still have to talk about parallel and perpendicular lines. So we need to deal with that, parallel and perpendicular lines. Some things about equations with that. So parallel and perpendicular lines and slope. The last thing to mention to you guys are here with me live, and anybody who's watching this later, this video later, remember that the spring schedule is now, it's not live, but you can at least go and see the spring schedule, that's now up on D2L, I guess, or however you access the schedule online. And I want to, once again, I mentioned this in the last lecture. Some of you have already heard this before. Some of you maybe haven't. Is that I will have 2 sections of college algebra that are online in the spring. And so I'm trying to recruit people. Would love to have you sign up for college algebra in the spring. The format of the class is going to be very similar to what I'm doing this semester. There will be a few minor changes, but not many. And but the basic premise will be the same. Live lecture by WebEx, online office hours by WebEx. I'll be on campus every couple of weeks before exams, exam reviews, WebAssign for homework. All that basic structure will be basically the same. So you guys are all used to the way I do things. And so that would be an advantage, I think, to taking college algebra. So anybody have any questions about that, about the spring schedule? I cannot say it louder. Whoever's talking, Anne Marie, say it louder.
Oh, sorry. Yeah, are you doing a mini master?
No, definitely not. College algebra is tough enough online. College algebra is really tough in the mini master. It's just a 3-week period, and it just goes incredibly fast. So it's really tough. Sandra, I saw that you had a question. So Anne Marie, you can take college algebra over the mini master. I think you could probably handle it, but it's a tough way to go, and it's over the holidays. And so that it just there's a lot of things that make it difficult to do in a mini-mester. I have taught college algebra in a May mini-mester, many times. I mean, it's a tough thing for students to get through. So, Sandra, I think you had a question, but I didn't see the whole question. I don't know if you want to. Let's see. So Sandra's question was about what comes up after Math 0310. And that actually is that's actually a much more complicated question than it used to be. And so for 0310, and there's some things here that
I've
still.
Lost sound on you.
I'm sorry?
I can't hear you.
Oh, wait a minute.
Yeah, we can't hear.
Yeah, I muted myself for some reason. I don't know. So Sandra's question was what comes up after 0310? And for 0310, it's possible that it's college algebra, depending on your major. But it's also possible that it's Math 1332, which is the liberal arts class. It's also possible that it's 1342, statistics. And actually also possible that it's 1324, which is finite math for business majors. However, okay, so all of these things require a little bit of a comment. So first of all, college algebra, first of all, talk to the university you're transferring to, go to their website and make sure you know what their requirements are for mathematics for the major that you have picked. That's one thing. That's the first thing you need to do. If you're not sure about how that is going to go, or if you need help with that, I am more than happy to help you out. You can email me or show up at my WebEx office hours, or we can arrange to meet on WebEx at a different time outside of my office hours so I can just talk just to you. But I'm really good at finding out those requirements. I've done that for many years. And so talking to me would be a really appropriate thing to do. I'd be happy to sit down and talk to you about it. College algebra is typically for science and business majors, typically, and psychology majors in some cases. There's other majors where college algebra is going to be a requirement. Some universities still require college algebra for virtually all of their majors, so it just depends. Liberal arts, like the name suggests, would be typically for history, English majors, possibly a criminal justice major, depending on what university you're going to. Again, 1332, you need to check and make sure that the university you're going to is actually going to take that for the major that you want to have. Statistics is frequently used for nursing and for psychology. And so a lot of times that would be the next class you would take in those majors. Finite math is for business majors, but typically business majors also have to take 1325, which is elements of calculus or business calculus. And you need college algebra for business calculus. I mean, even if it's not a requirement, I can't tell you enough that it is really ultimately a requirement. You need to get through a college algebra class before you take business cal. And since you've got to take it anyway, I would take college algebra first and then go to finite math and business calculus. So in 2 minutes, Sandra, that's a quick answer to Math 0310. Most people in general still need to go to college algebra, but definitely not everybody. And so you need to talk to the university that you're transferring to and think about the major that you've got. If you don't have a major picked, you're getting to the point where you need to be picking a major also. Something else that I'd be happy to talk to you about and happy to sit down with you about thinking about a major. Some of you may have, Charlotte and I were talking about this before the class started. Some of you may have thought in yourself, well, I'm not really very good in math, and so I'm going to pick a major that doesn't require a lot of math, and then all of a sudden you've taken Math 0310 or something like that, and you discovered, hey, I'm not bad in math. I'm better than I thought I was, better than I was in high school, and you're a different student now than you were in high school. And so, you may have opened up that avenue, definitely, where you think about a math or a science type degree after getting through a class like this. So all are things that I would be happy to talk to you about, absolutely. Email me. We can set up a time on WebEx where we can meet and we can actually discuss it one-on-one about what your goals are, and we can try to figure it out. So I'll be happy to help you out with that. or talk to a counselor. So, any other questions? Okay, I guess no other questions. So, look up your exam 2 grade. Come by my office hours, online office hours, if you have questions about material. Pay attention to WebAssign deadlines as they're coming up quickly again. And remember that I'm going to try to upload this lecture later. Whether I actually am successful or not is another story. We're going to give that a shot. And so hopefully I've corrected issues and and that won't be a problem. So everybody have a great day. Hopefully I'll see you again on Thursday in lecture. Have a good week.
See you later.
Thank you.
Bye.
Thank you. Thank you, guys.
Bye.